Tonight on the Astronomy Show, we take a look at back pain problems in space. BC Society of Skeptics Barry Beyerstein debunks astrology. We find out more about the Astro 2 shuttle mission with Dr. John Hutchings in Victoria. And of course, David Dodge with Astro News. All this and more on the Astronomy Show.
Reorganization on the home front creates more time for leisure. An educational opportunity presents itself to you through a family member. Waste no time in joining friends for outdoor activities or community events. Sounds ideal for an astronomer. Hi, I'm Dave Sableaf, and welcome to the Astronomy Show. This particular presentation, we're going to have a discussion on astrology versus astronomy. And as our guest, I have Dr. Barry Beyerstein, a psychologist from the Department of SFU Psychology, and also the chair of the BC Skeptics Society. Barry, welcome to the program.
Thank you very much, David.
First, I've got to ask you, what is astrology?
Astrology is a pseudoscience. It is very old. It's probably the psychology of 2,000 years ago, but we don't use the science in any other area of 2,000 years ago. There's been tremendous progress, and we've improved. We've thrown away old, discarded wrong ideas. And when I say it's a pseudoscience, what I mean is it has the trappings of a science. It claims to be one. It has the outward appearance of one, but it's really just old magic, gussied up and claimed to be science, but it is not.
We know that the importance of the planets and the person's house and so on. And I'm wondering, when we consider that astrology's been around for thousands of years, what did they do when they only had 6 planets? And now that we have 9, with 3 having been discovered in the last couple of centuries, doesn't this cause some problems?
Well, it should, and astronomers have pointed this out. And not only that, but we've discovered new planets since these old astronomical charts were originally cast. But astrology only deals with visible planets, and you as a knowledgeable person in astronomy know that there are lots of other bodies out there that don't happen to emit light that people can see, and so we're only looking at things that people 2,000 years ago could see in the night sky. Now we know there are all kinds of other things. But another important part is that if this system worked so well 2,000 years ago when it was being formulated, there should have been perturbations. There should have been little things that were wrong because the planets that hadn't yet been discovered by astronomers were casting their own effects, and the astrologers, if they really had been scientific, and of course they weren't in the way they came up with these descriptions, they should have been able to predict the existence of those other bodies, just the way astronomers did. That astronomers found that certain bodies that they were aware of behaved in slightly erratic ways, and they said there has to be some other force there has to be some gravitational pull or something, and that led them to deduce and then test the deduction and find that indeed there were other bodies there. Astrologers never did that.
Mm-hmm. Also, you have different constellations with different cultures having different names for them and characterizing as different things. Leo the lion, as an example, one culture would picture as being a lion, another culture would have it as something else, and yet it's referred to as Leo, and of course then everybody uses lion eyes and strong, etc. Wouldn't that be another example?
That's right. The different systems of astrology have different numbers of constellations to begin with, as few as 6 and as many as 25 in other systems, and the 12 that we have handed down to us just happened to be the one that the Greeks reworked from the Egyptians, who reworked it from the Babylonians before them. But you're absolutely right, that when you stare up at dots in the night sky, it's not like the children's exercise books where the numbers are placed there and you join 1 to 2 and 2 to 3 and so on. You're free to look at this just like an ink blot on a page of paper. And as you said, different cultures looked up and saw the same patterns in the heavens, but one culture happened to call it a lion because that's what it reminded them of, another called it a rabbit. And so it's really quite arbitrary, and the particular system that we have is the arbitrary one that the Greeks had. And so they took these particular dots at the top and superimposed their vision on it, and lo and behold, it became Leo the lion. And the one down below became Sagittarius the Archer. And this is really the entire basis of astrology, that people will say, okay, this pattern of dots reminded me of a lion, and therefore the people who were born with this sign in the sky, a sun in that section of the sky, to be more precise, must have leonine characteristics. And so it's what we call sympathetic magic. It's as above, so below. What does this remind me of? It reminds me of this object. Therefore, you being born in that particular relationship to it must have the same attributes as the object. And this is what we call sympathetic magic. And that's why I say it's a magical system. It's not a scientific system.
We've seen a situation where we've had movement of the rotation of the Earth on its axis. And with this rotation, as an example, we know that the North Star has been changing. That thousands of years ago, it was a different star. Thousands of years from now, it'll be Vega, which is one of the summer triangle bright stars. And that being the case, doesn't that mean there's been kind of a rotation of the different actual zodiac constellations?
That's right. I did find my diagram for this one. Of course, it's known to astronomers as the precession of the equinoxes, and it comes from the fact that the Earth's rotational axis, sort of like a top or a gyroscope, as it's revolving around its own axis, the axis itself makes a bit of a wobble, and that wobble causes what's called the precession. And as you said, the currently accepted North Star is the one that our axis more or less points to now, and at different times in the 26,000-year cycle it takes to make one of these wobbles, as I'm calling them, different polar stars will emerge as being lined up with the axis. And what that, of course, means is that most astrologers are using the systems that were worked out by the Babylonians and others 2,000 years ago, and we've actually moved about 1/12 of the distance around that precession. And so if you look at the sections of the sky, which is what your horoscope is actually based on in most systems of astrology, the constellations are no longer in the same positions in the sky due to that precession. And so, for instance, if you nominally think of yourself as a Gemini, and that's what an astrologer would call you and cast your horoscope, you in fact were actually born under the sign of Taurus. And so modern astrology doesn't even fit with the constellations anymore, but people are still using the system as if though it did. And so again, if the stars have anything to say about your life, which I doubt very much that they do, they weren't even in the right places to begin with for that kind of influence to be worked out by the astrologer.
I understand numerous studies have been done based on statistics of just comparing actual research or asking students and so on. I understand you do this in your own class to compare what they think about astrology and so on, and then find out if it fits the pattern, that there's so many that are going to be in this sign, so many in that sign are going to have these characteristics, etc. What are the results been in a lot of these studies?
Uniformly negative. That one kind of study takes classical astrology texts that astrologers agree on, and they say, all right, now astrologers say, that this particular sign, this one happens to be Libra, because the pattern of the stars reminded somebody of a balance. And so people who are in that, or have that sun sign, and supposedly have characteristics that indicate balance and equanimity and generosity and that sort of thing. And, again, just a straight magical ascription from balance in this image to balance in your personality and behavior. Now, the sort of thing that you can actually test from that is things like the following. All right, what kind of attitudes would somebody have if this kind of ascription of personality were true? Or what kind of occupation would somebody with these kinds of abilities and these kinds of attitudes tend to gravitate for? And so, or toward, that is. And so you can go out and you can find people in all walks of life, find out what occupation they are, and astrologers will tell you, that Libras make good beauticians, for instance, as it says in this that I copied from an astrology text. Well, you can go and check. I mean, are there more Libra beauticians or jewelers or artists than any other sign? Or, for instance, Mars is supposed to be the god of war, and therefore governs warlike activity. You'd expect people in the Marine Corps to be there in higher numbers with Mars in their horoscope than something else, and you don't. There's no evidence whatsoever. Another way of testing this is astrologers will tell you that some signs are compatible with others, and therefore, or two people with the compatible signs ought to fit together better than two people who have contrasting signs and are incompatible. So it's a simple matter. You simply go to the Bureau of Public Records and you say, if astrology has any validity at all, more people with compatible signs should get married to one another. They should bump off one another in society and have instant likes to one another, develop a relationship, get married. Similarly, fewer people with compatible signs should get divorced. It doesn't happen. And similarly, people with incompatible signs ought to get married less frequently if there's any validity to astrological personality ascriptions, and they don't. And so that's one kind of test that's been done numerous times, and it shows that the actual deductions from the theory of astrology can be tested, and when they are tested, they uniformly fail.
I was just going to say that I think I have some psychic powers myself, and I've got a feeling that we've run out of time, unfortunately. Barry, I want to thank you for coming down for the astronomy show, and I think we just scratched the surface, and perhaps in the future you could come back and we continue delving into this fascinating discussion about astrology versus astronomy and whether it's a pseudoscience or it's not in the near future. Thank you very much.
Thanks. It's been a pleasure. I'll be glad to come back.
Hi, I'm Chris Gaynor. Usually the subject of back pain only comes up amongst astronomers at the end of a strenuous observing session. But back pain has become a common problem amongst astronauts. The experts on back pain in outer space happen to be in Vancouver, and I'm going to be interviewing Dr. John Leadsom of UBC, who was the principal investigator in the spinal changes in microgravity experiment on the second International Microgravity Laboratory, which flew aboard the Space Shuttle Columbia last summer. Welcome to the show, Dr. Leadsom. Do you want to tell us why backs are an important problem that astronauts are having to deal with?
Well, it's important because they have back pain, at least for the first 3 or 4 days during flight, and sometimes it keeps them awake when they're trying to sleep and may interfere somewhat with what they're doing. We think the back pain is related to the fact that they grow when they're in space by quite a large amount, 2 to 3 inches. That's up to 70 millimeters in height. And that increase in height stretches the back and probably causes the pain that they experience. So we are interested in documenting how much pain they're having and what the increase in height is doing to their various bodily functions.
There have been back pain experiments on 2 shuttle flights so far. The IML-1 flight on Discovery 3 years ago and on IML-2 last summer. Do you want to tell me what the experiments were and the findings?
Yeah, in IML-1 we had pain reported daily on 3 astronauts, and we also measured the height of 3 astronauts twice during the flight using stereophotography. And that was the first time accurate measurements had been made of height changes. And by taking photographs of the back, we were also able to look at the changes in the shape of the spine during the flight. And we found that the normal curvature of the spine flattened out, but also that there was an additional height increase in addition to the spine flattening out. And that could only be occurring in the spaces between the vertebrae. This is a model of the spinal cord which shows you the vertebrae, and between the vertebrae are the discs, the spinal discs, and the only place that the body can increase in length is by these disc spaces expanding.
Because they're made out of soft tissue that can expand.
They're made of soft tissue, and the rest is solid and is bone. So we have to predict that these spaces are getting larger. Now on IML-2, we looked into this problem in much more detail. We again made measurements of height and also took stereo photographs and also looked at pain, but we also asked additional questions which were related to whether or not this stretching of the spine was actually affecting the nerves that run down the spinal column. All of the nerves going to the body. On this particular model, these yellow structures are the nerves which come out at every spinal level. And we thought that with the stretching of the spine, as well as this causing pain, it may be stretching these nerves, and when you stretch nerves, they don't carry their signals as well. So we established a battery of tests to look at nerve function.
Okay. Now, what impact could this problem have on long-term space flights, like say to Mars or something like that?
Well, it's of particular concern for long-term space flights because if the spine is being stretched and that stretch is being maintained for all of that period of time, and we now know from IML2 that that stretch is maintained for at least 14 days during that flight. It might be, if the nerves are being affected by the stretching, that effect will be greater the longer the stretch is maintained on the nerves, and it may be that if there are defects by the time they get to Mars, they may not be functioning too well.
Now, the growth that we see in space is also replicated on Earth. As a matter of fact, when people wake up in the morning, they're actually taller than they were when they went to bed at night. So this is a problem that we see on Earth. And how will the results that you find in space be applied for us Earthlings?
A large percentage of people have back pain. Some figures say at least 80% of us will suffer from back pain at some time during our life. Often we don't understand what has caused that pain, and we don't know very well how to get rid of it. Here we have a reproducible stimulus which is being applied to astronauts, which is stretching the spine, which we know produces back pain. And so we can study this, as it were, as an experimental model. We can't get volunteers in whom we can stretch the spine 2 or 3 inches on the ground. But astronauts are doing this all the time, and this, as it were, is a model that we can use. So by documenting the changes in the spine and the changes of the contour, what type of pain that generates, we can understand better what causes pain on the ground, and hopefully treat it more intelligently.
Okay. Now, you've run this experiment on 2 shuttle missions. I understand you're also doing some surveying of astronauts on other flights. What's the next step in this work?
Well, the next step, we presently would like to have data on more subjects. And NASA is doing some of that for us and is collecting data, particularly about pain. The astronauts are completing daily pain questionnaires on current flights, and we hope that we will collect data on somewhere between 20 and 50 astronauts so that we will have a better idea of what type of pain is being produced. But we really do need to make more detailed measurements on more flights, and we hope there will be opportunities together with the near flights and with future NASA flights. But we do have some interesting results from IML2, which may be setting us off in a slightly different direction. And that is that we found that the astronauts had a different response of their blood pressure to a standard exercise during the flight, which we would like to follow up, because astronauts, again, one of their other problems is, as you probably know, their cardiovascular system becomes deconditioned and they have difficulty standing immediately after return. And this is the first time that we've shown any changes in control of blood pressure during the flight.
Now, Dr. Ledson, we have here a piece of equipment that you were using in this, in one of your experiments. So, do you want to tell me what it does and how it works? And
yes, this is the flight model that we built to measure something called somatosensory evoked potentials, which is rather a mouthful. But what it in fact does is allow us to apply a stimulus to the ankle of the astronaut and then time how long it takes for that nervous signal to go from the ankle to the brain. It usually takes about 50 milliseconds to travel that distance. We postulated that if the spinal cord were being stretched and that was interfering with the function of the sensory nerves, that it would take longer than that normal period of time for the signal to go from the ankle to the brain, and this box gives us both the electrical stimulus and records the signal that arrives at the brain and times its arrival.
And it's hooked up to sensors which are attached to the astronaut.
The sensors are attached to the scalp to time the arrival of the electrical signal to the brain. This is a standard clinical test, but in order to fly the instrument, it's had to be repackaged into a much smaller space and be much lighter than the usual clinical instrument that's used.
And what did you find?
Well, we actually found that the time that it took for the signal to get from the ankle to the brain didn't change during microgravity.
Even though it had a slightly longer distance to travel?
It had the astronauts had grown, but we weren't able to detect a significant increase in the time that it took, even though it was a slightly longer path. That's not surprising, because the increase in height is a relatively small proportion of the total. If from one point of view, of course, that's good from the astronauts' points of view, that we haven't any evidence that there's a problem with their sensory nervous system. On the other hand, perhaps it's a little less exciting for us to not find changes, but overall we're quite happy that we're not detecting changes in the sensory nervous system.
Without a doubt, space is the place to do astronomical research. The Hubble Space Telescope is a prime example of that, but that's a very expensive mission. There are cheaper ways of getting into space, and later this month, or early next month, the Astro 2 mission will be launched aboard the space shuttle. With me tonight is Dr. John Hutchings, an astronomer at the Dominion Astrophysical Observatory. Dr. Hutchings, what is Astro 2 and what are its objectives?
The Astro 2 is the second flight of a bunch of telescopes which are actually flown on board the space shuttle. The whole cargo bay is occupied by these instruments. Actually, I've got a picture here which was taken during the Astro 1 flight. The same package was flown a few years ago, and here's a view inside the shuttle bay with these telescopes deployed and looking out into the sky. So what happens is that these telescopes get flown. That's the whole objective of the mission, to do nothing but astronomy. It will be of 15 days duration this time. There will be a couple of astronomers on board, as well as technicians and pilot and so forth, who will be doing these astronomy observations more or less in real time, in contact with a bunch of scientists on the ground, who will be looking at the data and assessing progress.
Well, now that the Hubble Space Telescope is fully functional, why is this mission so important?
Well, it's quite different. There are three main packages on board Astro, and they're all doing things that you cannot do on the Hubble telescope. There's an ultraviolet imaging camera which has a very wide field of view, many times, some 100 or so times wider than the pictures that you can take with the Hubble telescope, so it gives you a much wider view of the sky. It works exclusively in the ultraviolet, where it has very good sensitivity. The Hubble telescope doesn't do very well in the ultraviolet as yet, so that's a very different capability. There's an ultraviolet polarimetry package which also does measurements. Polarimetry measurements cannot be done with Hubble because of all the multiple reflections inside in the optics. And there's a Hopkins telescope which goes into the very far ultraviolet using special optical coatings that allow it to go into wavelength regions that Hubble cannot reach. So in all of these three packages, we're doing the kind of science that's unique and not possible with any other package at all.
Well, this is the second time around for the Astro mission. What did we learn from the first time?
Astro 1 has had a wide range of results on all these three packages I mentioned, plus they flew an X-ray telescope on the first Astro mission. There's probably hundreds of research papers, which would be very hard to go through in a short time, but the ones I'm familiar with have been some of the ultraviolet imaging results, which have in fact enabled us to pick out some of the very hottest stars in nearby galaxies, and have in fact led to further programs, some of which I'm doing on the Hubble telescope, doing spectroscopy of these very hot stars that we discovered during the Astro 1 mission.
And what will that tell us about the hot stars?
Well, hot stars are the brightest stars, and so in galaxies that are distant from us, in fact any galaxy other than our own, they are almost the only individual stars that we can study from here. They're the only ones bright enough, and therefore to study individual stars in a distant galaxy is telling us something about how stars live and evolve in very different environments, what the history of star formation is, what the history of that galaxy has been in terms of generations of stars that formed, and the recycling of material, the enrichment of interstellar material, and hence the second and third generations of stars that form out of it. Every galaxy we are starting to find has a very different history of how stars formed and how many generations have gone on, and what events led to star formation in galaxies. And so really this is the one handle that we presently have on that kind of research.
Thank you very much, Dr. Hutchings.
Thank you.
We'll be back in a few moments with Astro News. You know, it's evenings like this that makes me really glad I'm an astronomer. You know, with these cold, crisp evenings, we've got Orion due south, with stars marking his shoulders, stars marking his belt, stars marking his kneecaps. He really looks like a human out there in space. And below him is that bright star Sirius. Over in the east tonight we have the planet Mars rising just after sunset. Later this month, Mars comes into opposition when it's in line with the Earth and the Sun. And I challenge you to go out these evenings and watch Mars every time it's clear and notice its position. Tonight it's just above the star Regulus. Watch how it changes its position as the Earth catches up and passes Mars. Mars will first go in one direction, stop, and then start going in another direction. Well, there's not a heck of a lot to see in the nighttime sky this month. We have the phases of the moon. The first quarter is on the 7th. Full moon is on the 15th, and last quarter is on the 22nd. We have one very special event happening, similar to what we had in January when the moon passed Venus. Well, the moon's going to pass Venus one more time, but not nearly as close. On the morning of the 26th of February, the moon will pass just north of Venus. Well, as I said, there's not much to see in the nighttime sky except for the constellations Orion, the planet Mars. Directly overhead is the star called Capella, and just over the northern mountains is the Big Dipper. The two end stars of the Big Dipper, if you follow them out into space, point to a faintish star called the North Star. A lot of people are quite surprised that the North Star is not the brightest star in the sky. It is certainly not that, but is the star about which all other stars appear to rotate. The axis of the Earth points directly towards the North Star. So as we spin around our axis, all the other stars appear to turn in the opposite direction. Well, that's it for the Astro News. See you next month.
The preceding program was produced through the facilities of Rogers Community 4, Vancouver.